Hi class, welcome again to another session on biomaterials. So we have been discussing the various membranes that can be used for plasma separation. So plasma, like we all know, is the clear fluid without any of the blood cells, right? So we need to separate the plasma to remove the macro-sized toxins from the blood, for especially for people with renal failure. So, in the last video, I discussed about hydrophobic synthetic membranes. So, let us discuss the hydrophilic membranes today. So, hydrophilic membranes are basically of two types. One is synthetic and the other one is cellulose based. So, let us discuss the synthetic membrane first, and then we shall go on and discuss the cellulose based membrane. So, the synthetic hydrophilic membranes are similar in composition to a dialysis membrane. So basically, there's a difference between the dialysis membrane and the plasma separation membrane, and the main difference lies in the pore size. Because plasma has got larger molecules, so you just want to filter out the proteins and lipid molecules which are larger than other micro-sized waste such as urea and creatinine. I mean, of course, you don't want urea and creatinine in the blood. At the same time, there are other toxins which are larger and which have got larger size than the pores for a dialysis membrane. So therefore, you need plasma membrane to separate those. Just a revision of the last video. So the hydrophilic synthetic membrane are similar in composition to a dialysis membrane and are most commonly manufactured using polysulfonone or sulfone, sorry, PSU it is called, or polyether sulfone, which is called PES, or polyvinyl pyrrolidone, right, PVP. So other materials used are polyvinyl chloride, which is PVC, PMMA, and PVA, which is polyvinyl alcohol. So of all these materials, PSU and PES are widely popular polymers because not only can they be used for manufacturing hydrophilic synthetic membrane, they've got other industrial applications as well. So manufacturing membranes with these material can be beneficial to a company because if they can't sell it as a medical as a biomaterial, they can always find other uses for it. So the membrane formation using these polymers is achieved by a solvent-induced phase separation process, or it's called a SIPS. So in the SIPS process, the basic polymers such as PSU plus PVP or PES plus PVP are dissolved in a mixture of solvents, right? So another method of producing hydrophilic synthetic membrane is through a method called as DIPS, which is diffusion induced phase separation. So in this method, uh, you know, um, basically this method is used for producing capillaries. So uh, capillary type of membranes, tubular membranes, where the polymer solution is pumped through a ring-shaped spinneret, and simultaneously a co-liquid is pumped through an opening in the center of the ring spinneret to prevent the capillary from collapsing into a simple thread. So when I say capillary, I want a tube-like structure, right? I don't want a thread-like structure which is solid. So I want a hollow tube-like structure, and that tube can be formed by simultaneously pumping a core liquid and the polymer solution. So when the core liquid is basically a water-based mixture, and the polymer when it comes in contact with the core liquid through an opening in the center of the ring spinneret to prevent capillary from collapsing into a single thread. So when the polymer solution comes in contact with the non-solvent, it precipitates from the solution and forms the membrane wall. So cellulosic hydrophilic membrane are similar to the membrane used in dialysis and are produced in a similar way using cellulose acetate. So cellulose acetate is dissolved in an acetic acid solution and spun through a ring nozzle into a precipitation bath with low concentration of acetic acid. Right, so basically you just use cellulose acetate. I mean, cellulosic hydrophilic membrane is actually a natural cellulose is natural material, right? So you use cellulose acetate. So it is I mean it is a natural polymer, and the membranes, obviously, the biocompatibility properties would probably be superior to the synthetic membranes. So cellulose acetate is dissolved is a primary polymer here, and it is dissolved in acetic acid solution and spun in a ring nozzle into a precipitation bath, which has low concentrated acetic acid. Now, a bowl liquid or the core liquid is injected through an opening in the center of the ring in order to keep the nozzle open, because as the polymer material passes through it, there are chances that the nozzle might clog. So, in order to keep it open, a bowl liquid is continuously injected through the center of the ring, and then the capillary, which is produced after through the ring nozzle, it is washed in several steps with water, and the final washing step involves the use of pore stabilizing liquids such as glycerol. So um, the material is continuously washed in water in several steps. It's not just once it is dipped in water. It's dipped in water in many steps, and then finally it is dipped in glycerol. So glycerol not only retains the moisture of the material and enhances the hydrophilic properties, it also stabilizes the pore, so that the material will have optimal pore size to allow plasma to pass through it. I think that's all I have to speak about plasma membrane. I hope you had a fruitful session learning about it. In subsequent videos, we shall discuss the blood oxygenating membranes as well. So, thank you very much for joining me today.